Finishing up here in part 3. Remember, we found this to be 0.927. Yeah, the calculator spit out a negative at us, but that's only because it's telling us what quadrant we're in, okay? We care about this guy right here that'll take us over to there. So if I'm trying to write a polar coordinate for -3, 4, I have a radius. I need to know how far to tilt this guy this way. If you looked at this, okay, it says if it's in quadrant 2, we want to add a pi to whatever the inverse is. If you think about it that way, pi plus the minus gets us less than pi, which sounds right. I prefer to think about it this way. If I know this is 0.927 radians, I know this right here is 3.14. So I would rather do 3.14 minus 0.9272. Okay, so basically 2.2. I know that this guy clearly can't be bigger than 3.14, but it's got to be bigger than 1.57 because there's pi. Okay, but that will spit out the negative at you. So we'll call this angle just a positive here, and then we'll call this 2.2. If you want to convert that to degrees, go ahead and do that. So let's say this was like, I don't know, 30 degrees. Well, if we want where it actually falls, we'd say 150, 180 minus that. But we haven't been using these tangents before where they're going to spit out negatives. So just take the positive here and say, well, this huge thing is 180 degrees, or 3.14 minus that. So once we know now that this theta 2 is 2.2, here was our rectangular xy. We know anything in polar is just r comma theta. So we just say 5 comma 2.2. That's how I want you to write your answer. Okay. So if I looked at that, I'd say, well, clearly it's got to be in quadrant 2 because this is 3.14 radians. It's got a radius of 5, so it should match up with that. There's one other thing we're going to look at in class tomorrow because I'm going to give you guys too much here at home, but it can get a little dicey here, so take some time, rewatch lessons, make sure homeworks, practices are all good and whatnot, and we'll see you guys with questions here tomorrow.